Okay, so we're going to balance some redox reactions using the half reaction method. And I'm going to tell you that we're not going to do too many of these because towards the end, it gets really complicated and beyond the scope of our course. So we're just going to do the first couple, and then that's going to be it. So only the simplest ones. Beyond that, you might see that in a college course, but not here. Okay. So the first thing you need to do is assign oxidation numbers, which in the first one it is already been done. So then we need to say, okay, who was oxidized and who was reduced. So don't forget, Leo the lion says gur. Wow, that was weird. Which means the loss of electrons is oxidation and the gain of electrons is reduction. So who lost electrons? That was tin. Tin went from Sn0 to Sn plus 2. Now, we are balanced for mass, one tin atom on both sides. So now we just need to balance for charge. So this side has a charge of 0 overall, so I add 2 electrons to that side. Now this entire side right here is neutral. So we are good for our oxidation. And this is an Sn, by the way. So that means the silver was reduced. Silver atoms are the same on both sides. Good. So now I need to add my electron over here. So now we are balanced for mass and charge for the silver. However, you'll notice that we lost 2 electrons, but only gained 1. And so the law of conservation says you can't do that. Well, I didn't want all that stuff to be erased. Anyway, so if we need to balance this entire thing here, this entire thing needs to be multiplied by 2. So any of the silvers need to have a 2 in front of it. So that would be a 2 here, and that would be a 2 here, which means that would now be, if I weren't to just keep it in parentheses, it would be 2Ag plus and 2E minus yields 2Ag0. So now we've gained and lost 2 electrons each. Okay, so that's all you do. Next one. Again, our oxidation numbers have been provided. Thank you. So who lost electrons? And when you lose electrons, you become more positive. That's chromium. So I'm good on mass. 1 chromium on each side. So now I need to figure out, okay, if this whole side is 0, this has to be 0 as well. So let's get rid of those. Okay. So then my lead plus 2, lead 0, which means I'm gaining electrons here, 2 electrons. So I lost 3, but I gained 2. So that's not going to work. So we need to find a common multiple, which is going to be 6. So this is going to be multiplied by 2. This is going to be multiplied by 3. And so then any chromium is going to have a 2 out front. Any lead is going to have a 3 out front. Okay? Finally, we don't have oxidation numbers provided to us. So let's do that. So remember, our entire compound needs to have a sum of the oxidation numbers of 0. So I'm going to do what I always do, which is assign oxidation numbers to the ones I know. So I know potassium has to be plus 1. And I know oxygen has to be minus 2 because this is not an exception. So this means overall my oxygen is minus 6. So what does chlorine have to be? It has to be a plus 5 in order for everything to balance out. Over here, we're going to have a plus 1, minus 1, and this is a 0. And again, why is that 0? Because it's not gaining or losing in a compound. So, sorry, this says plus 1, plus 5, minus 2. Okay, so who lost electrons and was oxidized? When you lose electrons, your oxidation number goes up. So K went from a plus 1 to a plus 1, so it's not K. Cl went from a plus 5 to a minus 1, which means it gained. So oxygen went from minus 2 to 0. So bring everything having to do with oxygen over. All right, so first thing I notice is that I don't have the same number of atoms. So mass is already wrong. So I'm going to say I have 3 here and 2 here. So I'm going to need 2 here and I'm going to need 3 here. So then I'm going to say, okay, now my masses are good. I have 6 oxygens on both sides. On this side, I have 2 times 3, which is 6, minus 2 is minus 2. So that's minus 12 charge. Okay, so 6 minus 2. I'm minus 12 on this side, and this is 0. So how do I get a minus 12 charge? I'm going to have 12 electrons on that side. So now again, we've got minus 12 charge on the left, and we've got minus 12 charge on the right. Nobody said that both sides had to be equal to 0. They just have to be the same charge. So then we've got Cl plus 5, and then we have Cl minus 1. So a reduction is a gain of electrons. So how many electrons is it going to take? If I'm at plus 5, I'm going to take 6 electrons. So then I'll have both sides are equal to minus 1. So you can see both of those are not equal. So if I multiply this by 2, now I'll double everything. So anything with a Cl gets a 2 out front. So a 2 goes there and a 2 goes there. And then anything with an oxygen, the O2, that has a 3. So there's that.